So, good morning, students. So, welcome to IIT NEET Foundation, our Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So, once again, welcome all the participant class 7th students for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 7, our ongoing chapter number 7, circular motion. And today we are entering into the session number 2. So far we completed one session about a special type of motion, that is circular motion. Because we already know about motion. We already learned much about the motion in the first chapter, which is nothing but change in the position of a body with respect to time. So there are different types of motions are there, like linear motion, translatory motion, vibratory motion, oscillatory motion, random motion. Apart from all these things, there is a special type of motion called circular motion. Right? Circular motion is nothing but following a curved path about a fixed point. When a body covers, for example, a body starts from A. When there is no force act on this, it will go straight only. But whenever there is a force is applied, it changes the direction. From every point, there is change in direction and follows the curved path. And this motion is called circular motion. Right? When a body moves along the curved path about a fixed point, is known as circular motion, which is one of a special type of motion. So when you are studying about the motion, we study about what is the displacement, what is the velocity, what is the speed. So these terms which we learned in the motion, here little changes when you are studying about the circular motion. The terminology will change. Then why body is moving in circular motion? How it is moving in circular motion? That we learn today. What is the reason for what kind of force is acting on a body to make it into circular motion? This not only happens in the practical, in the regular also it happens, because you know Earth is revolving around the sun. Earth is revolving around the sun in a circular path. Electrons are revolving around the nucleus in circular path. So many examples. When you go for the exhibition, circus, you can see the giant wheels and different types of play. You can see where there is a circular path is there. In your school also, there may be some playing items which follows the circular path. So circular motion is the very, very, very important type of motion, right? So in last class we discussed about what is the circular motion. The circular motion is of an object is along circular path is called circular motion. See, this is. So a motion of an object along a circular path. See, it is moving a circular path like this. So this path is called, this type of motion is called circular motion. In that again, uniform circular motion. Uniform, constant speed. When a body moves along circular path with constant speed, its motion is called uniform circular motion. Example, you can see motion of the planets around the sun. Not only Earth, others also, Mars, Jupiter, Pluto, all are following a circular path with constant speed. They are not running, they are not rushing speed, or they are not tired. After tiring, if they take rest. Suppose, imagine, this is sun, right? This is Earth. So Earth is moving around the sun from last millions of years, 400 million years. Suppose Earth is got tired. Earth want to stop here for some time. We want to take rest. Want to have some tea. What happens? Earth will fall into sun. Earth is fall into sun to stop. As long as it is moving around the circular path, it is safe. We are safe. Suppose, see, when you go to the circus, a person moves around the globe. One globe, a person moves to the bike. If you remember, will go with a great speed around the globe. When he reaches the top point of the globe, his head is down. He is reversed, but still he won't fall down. He'll continue like that only. But suppose after going up, if you apply some brake, he'll fall down. Applying the brake is nothing but he wants to stop. Just now we have seen yesterday video also. Whenever bucket full of water, when you move circular path, even though bucket goes to the topmost point, no single drop of water fall down, as long as you continue to rotate. But when you stop rotating, all water will fall down. That means there are some forces acting on a body moving in a circular path. So today we are going to discuss about those important forces, right? So before that, just let us see about the examples, motion of the planets and motion of the satellites also around the planets. And because every planet has number of satellites, so many satellites are there, right? Then the tip of the second hands of watch, second hands will move continuously, it's the same only. When you move the 60, 1 minute, 60, 1 minute. So it always moves constant speed only, right? A stone tied to a string and rotate, whirling it. That also follows the uniform circular motion, right? So what is happening here? So suppose, see here there is a body is there. Here some body we started A. Actually, when there is no force acting on that, it moves in a linear motion. But whenever some force is acting on the body and makes the body to change the direction, right? So there is a continuously force is acting on a body to change the direction. So at every point there is a change in direction. Even though it is moving the constant speed, there is acceleration on a body in a circular motion. In uniform circular motion, body moves the constant speed but possesses some acceleration because it is changing the direction at every point. At every point there is a change in direction because some force acting on that. So because of that force only we are getting the acceleration, right? So see here, every point very important. So there are some terms, important terms related to this circular motion. First one, radius vector. So whenever there is a circular motion, there is a radius with there, but from a fixed point to the body, this point, that is called radius. As the radius is constant throughout the circular path, it is called radius vector. It is a particular direction. As the radius moves in a particular direction, first it is here. After some time, it moves here, like this. It is follows a specific path, right? So a line joining the center of the circle and body directed outwards is called radius vector. Center of the circle and body, P. This is called radius vector. Why you are calling vector? It follows a specific direction. The first statement here, first term. So generally in case of linear motion, we call it as a direction, straight line. But here it is a radius. So radius vector is the first term. Second, angular displacement. We know what is displacement. Displacement is nothing but changing the position of a body in a specific direction. But angular displacement means angle. Angular means circular motion. See here, example. Suppose a body is here, O to A. The first, this is radius vector. After some time, it moves to A to B. So OB is another one. So this here makes some angle here. To move from OA to OB, it makes some angle. That is, this is the displacement. Arc is the displacement. So angular displacement of particle undergoing circular motion is defined as the angle turned or swept by the radius vector from one position to another position. It is represented by a symbol. Symbol is there here. Pi, I think. There is a pi is a symbol here. Read as a theta. Theta you can say. So theta you can see like this. So theta is then the angle is represented by theta. the THETA. So what happened here? See, first it is at OA, right? It moves from OA to OB. So this is the moving from here to here, so making angle theta here. This theta is called angular displacement. The second important term, like is given in the formula also. The displacement is R into radius into angle. The radius into angle will give the displacement. Right? So length of the arc by radius of the arc. Length is nothing but this. Length of the arc is nothing but AB. Okay. This is length of the arc and radius. Will give the angular displacement. The angle made by radius vector. The angle made by the radius vector from one position to another position. Okay. Is called angular displacement. So radius vector and angular displacement are the two important terms. And then, so when you come for the unit here, radian is the unit for the angular displacement. Radian is the unit for the angular displacement. Then angular velocity, commonly we call it as velocity in motion. But because we're making some angle, it is called angular velocity. Rate of angular displacement. We know velocity is nothing but displacement by time, right? Correct. But here angular velocity is nothing but angular displacement by time. We know angular displacement is right theta by time. And change of displacement by time is called angular velocity, which is denoted by omega. Omega is equal to angular displacement by time. The angular displacement per unit time is called angular velocity. It is represented by symbol omega. Or the rate of change of angular displacement. So which is measured in radian per second. Because you know theta is radian, t is second. Radian by second. Clear? Very interesting. Three definitions. Radius vector, angular displacement, angular velocity. Now, so when you go for another one, time period. So time period, you know, particle in a circular motion to come defined as time taken by it to complete one revolution. Suppose its center point, a body started from here, A. So it follows the circular path and completed up to here. Again, it came back. So this is called to time taken to complete one. Just like our time period of the earth. To complete one revolution is 24 hours. Or 365 days. So that is called the time period. Time taken by a particle to complete one circular motion. Okay. Next, frequency. So the number of revolutions made by a particle per second is called frequency. So you know one complete revolution is about 2 pi as per the mathematics. 360 degrees. Right? 2 pi by t. Displacement by time. So the uniform circular motion as a speed is constant. Equal angles are swept by the radius vector in every second. In case of uniform circular motion, we know constant speed means at every time it moves the same angle. Okay. Then angular acceleration. We know acceleration, the rate of change of velocity. But here, the rate of change of angular velocity is called angular acceleration, measured in radian per second square. They will measure the meter per second square. We have radian per second square. So, very important terms: radius vector, angular displacement, angular velocity, time period, frequency, angular acceleration. These are the terms which are similar to the motion, but they change in terms of angle when the body in a circular motion. Clear? Right. So we move forward again for some more information. So here everything is given. Rate of change of angular displacement is called angular velocity. That is omega is equal to, already I told, omega is equal to theta by t. Okay. So from that, linear velocity is nothing but relation between linear velocity is v. Common. Linear means when body is moving in a straight line, linear velocity. But when body moves in a curved circular motion, it is called angular velocity. Omega. Omega is the angular velocity. So what is the relation between those two? Is given by linear velocity is called angular velocity into. So V is equal to R omega is the relationship between linear velocity and angular velocity. Only the difference is radius. Why radius is coming? Because circular motion. Okay. So totally we learned about the very important terms here. One is about the radius vector. Second one is angular displacement, angular velocity, time period, frequency, angular acceleration, and the relationship between linear velocity and angular velocity. V is equal to R omega. Right? Linear velocity is equal to angular velocity into radius of circular path. Clear? This is overall the synopsis number 1. Now, when you enter to the very important part, so why body is moving in a circular path? When it is moving in a circular path, why it is not falling into center? Suppose electrons are there. Electrons are moving around the nucleus from so many years. All the planets are moving around the sun from millions of years. Why they are not falling into the earth, sun? Why they are not falling into nucleus? How come they are able to manage to move? Suppose if I ask you, I made one circle in the ground, I ask you to run around the circle. How much time you can run? Maybe 10 minutes, 15 minutes, 20 minutes, 30 minutes, 1 hour. After that, what happened? You will fall down. But why Earth is not falling down? What is the secret of Earth energy? Is it boost is the secret? Or Horlicks is the secret? No. That means there should be some forces acting on Earth. First force is helping Earth to move around the circular path, move around the sun. Second force is something is balancing the Earth, not to falling into sun, or electron, not to falling into nucleus. Those forces are, you can see on the screen. Centripetal and centrifugal forces. These are the two important forces acting on every body which is in a circular motion. If these forces are not there, there is no possibility of the circular motion. They may be in the different forms. Centripetal may be different forms, centrifugal may be different form, but definitely on a body in a circular motion, these two forces comes into play in opposite direction with same strength, same magnitude. So very, very, very important types of forces comes into play when body in circular motion. Right? So before going for this explanation, let me show you one video on these kinds of motions. Then we'll move to the topic.
Hello friends, let's see an interesting activity. Why is the nut coming to the center? Because of centripetal force, right? Hi, this is Meena Nazunkar. I just gave a small demo of how I started session in my class. Here I performed this activity to get your attention. I did the same in my class to get the students' attention. And I found it's a great way to introduce the concept of centripetal force and centrifugal force. Here, I will explain 3 easy and interesting hands-on activities that will help students to understand the concepts better. Each activity will just take 10 to 15 minutes. Let's come to our introductory activity. Here, we can ask students to rotate the balloon in different directions so that it will help students to bring their attention to the motion of the nut. After with the nut, we can also try this activity with a coin and can ask the difference between with a nut and a coin to the students. This activity made the students to think why the nut is coming to the center. And this small demonstration helped me to introduce the session's topic. Here, I will again explain 2 simple activities for the centrifugal force. For this activity, we need a thread, a plastic cup, a paper cup also fine, some
And this
water,
has a sign
and a
and the
needle.
activity also.
Make 3 holes on the rim of the cup at equal distances. Pass each thread of equal length through each hole and tie the threads together. Attach a foot of thread at the common points of these threads. Fill half a glass with water. Now hold this assembly like
See.
this. Rotate the cup with swift action. Now observe what happens.
This is very easy.
This
to
activity
bucket.
would take approximately 5 minutes. After this demonstration, students were curious to know why the water is not falling down even if the glass is upside down. And with the help of this activity, they understood the concept of centrifugal force clearly. In discussion with the students, you can ask these questions like, why is the water not falling down even if the glass is upside down? What is opposing the water not to fall? After explaining the centrifugal force, it made the students to understand it clearly. We can also give a small puzzle to the students to explain the centrifugal force. We will make a spinner that we will rotate on our index finger. For that, we will need a piece of rubber and 2 broomsticks. Here, we can ask the students what is the direction of the force. They may relate this activity with the previous activity and try to answer. Let's see one more activity to explain the centrifugal force. Students can directly perform this activity under the teacher's guidance. Let's make the assembly
See,
using
everywhere-
2 transparent plastic glasses, 2 plastic balls, sellotape. We can ask the students how can we separate these balls without touching these balls and without destroying the assembly. After performing the activity, you can ask these questions to the students. What kind of motion separates the balls and why? I think it's now a good time to explain the definitions of centrifugal force and centripetal force. Now we can give another puzzle to the students based on both the forces.
See,
The smaller ball has to lift the big ball up. How can we help the smaller ball to lift the bigger ball up without touching any of the balls? This is a good example where
Very
the students
interesting.
can apply both the concepts of the forces. We can give few chances to the students to solve this puzzle and to know the reason. We can ask the students about the motion of each ball and the forces acting on each ball. For a quick revision, we can ask questions like, explain the concept of centripetal force and centrifugal force. Draw simple diagrams showing the direction of centripetal force and centrifugal force. Give examples of day-to-day life where the centripetal force and centrifugal force are used or experienced. In activity C, identify the types of the forces. Also, identify the type of the motion of the each ball. After a week or so, we can elaborate this concept by asking these questions to the students. How can we separate the butter from the buttermilk? How do
Tell me.
pathologists separate the blood cells from the blood? Students can be asked about the exploration of the revolution of the planets and the effect of the centripetal force and the centrifugal force on their revolution. Why the earth is bulged at the equator? These questions can be given as a homework and teachers can discuss the answers in the next period. Or students can be asked to perform the following activities in extra classes or off periods. The links of these activities are given below in the description box. Since I started performing
right. So it's a clearly explained that there are so many activities they shown which you can do in even in Science Adda program. I'll share the details with you in next Science Adda program. So what is they want to explain is any body which is moving in circular path, to make the body to move in circular path, the responsible force is centrifugal force. The force which always acts away from the center, the force which always acts away from the center and makes the object to move in a circular path or towards center, acts towards center and makes the body to move in a circular path is called centripetal force. Very important force this is. Without this force, we cannot imagine the body to follow curved path. If this force is not there, body will go only in straight line. Because of this force only, for example, when you are whirling the stone, the centripetal force is supplied by your finger. This finger, if you won't turn the finger, the stone won't move in a circular path. Means this finger is supplying the centrifugal force, centripetal force, right? So, consider a particle revolving on a circle with O. Suppose say this is a circular path. and radius r. Right? So, see, according to Newton's first law, of motion, what do you know? Which until unless force is not applied, the particle tends to move along tangent because of the inertia of direction. So at every point, body should go like this only. But why it is taking turn? Because of the force acting on that. Otherwise, the direction of the body is perpendicular to the point. Every point you can take in circular path. The body should go perpendicularly. But because of the force only, it is taking turn. That force is called centripetal force. So thus, the force must be acting on a direction normal to the direction of the particle called normal force. Right? But because of the force acting on the particle at every point, the body is taking turn. Body is taking turn and changing the direction. So that force is called centripetal force. And the acceleration of the body is called centripetal acceleration. All will come later. One by one we'll discuss, right? Then, when a body is okay, moving in a circular path, I told why it is not, for example, we consider one circular path. So this is the center point, this is the radius. Right? So force is acting on a body like this to make the body to move. This is centripetal. Centripetal force acts towards the center. That is called center seeking force also. This is called center seeking. Center seeking force acting towards the center. But when force is acting towards center, body should come towards the center. Why it is not coming? Why Earth is not coming to the sun? Why electron is not falling into nucleus? Because there is another force acts away from the center. That force which is acting away from center is called centrifugal force. It is also called center fleeing force. Away from center. Towards center, away. Means there are two forces acting on same body but in opposite direction. What happened to the body? Body remains in same orbit. Means both forces are of same magnitude, same strength. On Earth, two forces act. One is gravitational force of the Earth, gravitational force of the Sun. So as their force is same on Earth, Earth is not moving, it is only on same orbit is continuing. Even electron also, there is a electric force. That is attractive force acts on between nucleus and electron, so that electron will continue to revolve in the. So the centripetal and centrifugal force may be in different forms. They may be in the form of gravitational force, they may be form of electrostatic force. But what is their duty is, one is acts towards the center and makes the body to move in circular path. Other one is acting away from the center and making the body to remains in the same orbit without falling into center. But centripetal force is the real force, whereas centrifugal force is the imaginary force, also called fictitious force. We cannot see that force. We cannot see centrifugal force. Why you are thinking? Because of the Earth is revolving in the same orbit without falling into sun, there may be some force acting on. We can experience that one. We can experience, but we cannot see. But centrifugal force we can apply. The applied force is centripetal. That's what it's called. It is a real force. Okay. So that is about the two important kinds of forces acts on a body when body is in a circular motion. So when a body is in circular motion, what you have to think is, so when body is in circular motion, there are two kinds of forces acts on a body which are given by the mathematically also. F is equal to mv square by r is the formula for centripetal force or centripetal force, right? It is also can be written as F is equal to mr omega square also. Why? Because you know V is equal to r omega. The relation between linear and angular velocity. If you substitute here, to substitute that value here, you get the same formula. The magnitude of centripetal force is given by mv square by r. If V is not given, we can convert into omega form. In place of V, you can substitute R omega. So what will get? F is equal to M R omega square whole square. Sorry, R omega whole square by R. That is M R square omega square by R. R cancel. M R omega square. So both are the formula for the centripetal or centrifugal force. In case of centrifugal, we'll get the minus. Why? Because opposite direction. If you take centripetal as a positive, centrifugal becomes minus. Their magnitudes are same, but acts in a opposite direction. Suppose on you, 100 newtons are acting on you in opposite direction. What happened to you? You become sandwich. You cannot move either this side or this side because equal forces are acting on you in opposite direction. The same happens in the case of Earth or electron or any body moves in a circular path. Those two forces are named as centripetal force and centrifugal force. Right? Hope you are clear. So what we'll see in next class is we'll go to the in-depth about the differences. What is the difference between centripetal and centrifugal? So centripetal force is acts towards the center. Centripetal force acts away from center. Centripetal force is called center seeking force. Centrifugal force is called center fleeing force. Centripetal force is given by mv square by r. Centrifugal also given by mv square by r, but in a negative direction, opposite direction. So centripetal force is responsible for the body to move in a circular motion. Centrifugal force is responsible for making the body to move in same path, same orbit. Okay. So like that, there are various differences you can find between these two. Centripetal force is the real force. Centrifugal force is the imaginary force or fictitious force. Or pseudo force is also called pseudo, means imaginary. Clear? Is mentioned C. Center seeking force, center fleeing force. Okay. So the force which continuously deflects particle from a straight line path and makes the travel along the circular path is called centripetal force. So which is given by mv square by r or mr omega square. Examples: centripetal force is the must force for the uniform circular motion of the body. Earth goes around the sun because of the gravitational force attraction between them. The gravitational force here is the centripetal force. Right? Revolution of planets around the sun. Next, suppose a body is rotating in a circular motion path. Let centripetal force suddenly vanish. When centripetal force vanishes, now the body would leave the circular path. For observation, standing outside the circular path, the body appears to move in a tangential direction. For example, I tell, when you are rotating, take one small ball, tie it to a thread, keep rotating. It moves in circular path. Suddenly, if you cut the thread, then where the ball will go, it will go tangential direction. It won't follow circular. That is tangential. Actual direction of the ball is tangential, but because of this force only, it is following a circular path. So these are the two forces which are responsible for the body to move in a circular path. Whether it may be moving with a uniform speed or they may have acceleration also. Clear? So in next class, we'll discuss in depth about the differences. What is the major difference in the table form about the centripetal and centrifugal forces and some solid examples also. So here there are the all possible rotations, revolutions. So when your body is moving around itself, it's called rotation. Moving around the other body, it is a revolution. Okay. Or just like Earth. Earth not only spins around itself, it also moves around the sun. Clear? Right. So next class we'll discuss the differences and we have some solid examples also. So define angular velocity, write in units. Right. Angular velocity is nothing but measuring the radian per second. Angular displacement angular velocity, vector, radius vector, angular acceleration, what we learned day to day. So many terms when a body is in circular motion, and so many important forces to make the body to move in a circular motion. Centripetal and centrifugal forces. Clear? Very important chapter, even though it is a very small chapter, very important. We'll conclude this in the next session, next week, right? So note down that home task, homework, define angular velocity, write its units. So Jogipet, Balangpet, Medchal, Oakley, Pujareddy, I don't know which, attending all classes, which branch it is, Ramnagar and Falaknama. So hope you are ready for the test 6, which is coming Monday, with the syllabus of work, power, energy, chapter number 6. You prepare well, right? So thank you all of you. Have a wonderful day. Have a wonderful weekend. Thank you.